So we're doing 2.1 vertex form of quadratic functions. Everything we do in here every day, I will be recording and posting it. So if you guys are not here, you go to YouTube. Please click in there. You go to YouTube and you watch the video. They are labeled in the Algebra 2 folder. They are labeled the date and if it's a section number, I'll say today is going to be 2.1 day 1, and it's going to have the date. So you're going to know the day that I did it. Okay, so we're going to be using vertex form of a quadratic function. Now we have done some of this already, so that's why we took that quiz yesterday, so I could see where we're at. Now it says a function is a quadratic function. Its equation can be written in the form f of x equals ax squared plus bx plus c, where a is not 0. If a is not 0, if a is 0, that would be no x squared, which would make it a linear function, correct?
Yes.
Okay, so a can't be 0. That's all it means. If a is 0, then it's linear. It's not quadratic. The quadratic parent function is f of x equals x squared. That's the parent function. That's the original function. No changes, pure. All other functions go from the parent function. We talk about the relationship to the parent function. The shape of a quadratic is a what? We've talked about that before. It's a parabola.
Oh.
The shape of a quadratic function is a parabola. It may look like a wider parabola or a skinnier parabola, but the shape will always be a parabola if it is a quadratic. The form that I initially told you, this is usually called standard form. It's going to blink. It's an R. My pen doesn't like to work right. Okay, that's standard form. And vertex form, have you seen vertex form before?
No.
That is not a correct statement. In here, we've used this.
Oh, yes.
We've had a times x minus h squared plus k. We did it in topic 1. Now, we didn't do it in great detail, but we did do it. So this section, this part, there's a couple, like 3-4 sections in topic 2 that all deal with quadratics and different ways to graph them. And it's going to be going off what we did in topic 1. So this picture right here is just the parent function. In my 0, 0, my vertex is at 0, 0. And when I plug in 1, I get 1. If I plug in negative 1, I get positive 1. And I need to recalibrate my thing is sliding down. I'm not quite sure why. So we have looked at quadratic functions in here already this year. We are going to be looking at them in more detail. Okay, Keelan, what did I just say I had to do?
Yeah, I know you have to recalibrate.
Okay, so I didn't do anything else. I have to recalibrate.
I didn't know if you like switch slides.
No, I have to recalibrate.
Yeah.
Okay,
Thank you.
so again, what is my parent? What is my shape of every quadratic?
A U.
No, won't accept you. What is the shape?
Parabola.
It is a parabola. It opens up or it opens down, right? It will be wider or narrower. We can move it left, right, up, down. So we're going to be doing those things. Today we're going to be writing in quadratic and in vertex form. I'm pretty sure that's what we're going to be doing today. So ax squared plus bx plus c is standard form. A times the quantity x minus h squared plus k is the vertex form, where h and k is the vertex. if I were to write the parent function in vertex form, it would be f of x equaled 1 times x minus 0 squared plus 0. Because the vertex is at where? 0, 0.
Yeah.
That is so much more nicer, not gonna lie. They're actually reading the stuff. Makes sense. And is it all
Joe,
like
can you
crammed
cover
into
your
one?
nose, please? Okay, we good now?
Hold on.
Sauce, no. So,
Okay, we good?
no.
How close are you?
I think it's the last thing, but right.
Someone wrote on your desk.
It was definitely you.
No, it wasn't me. I literally just read it. I can't even write that small. It's insulting too.
Okay, I'm done.
Okay, I know who's up there, so I'll come with it.
All right.
Okay, so now this is just what you had written at the very last thing, so you can label it. Okay, the only thing different is what's the only thing about different what I have written here that what was written? What's in front of the A now?
Plus.
Plus or minus. Okay?
Yeah.
So the plus or minus in front of the A, if A is greater than 0, what does that mean? What kind of a number
Opens
is
up.
greater than 0?
Oh, like 1, 2, 3.
Positive,
Yeah.
right? So it opens up. If A is greater than 0, the graph opens up.
Down.
If A is less than 0, meaning it is what?
Negative.
Negative, it opens down. We've discussed this already, right?
Mhm.
Okay. Now, if the absolute value of A is greater than 1, the graph changes quicker than the parent function, making it narrower. If the absolute value of A is between 0 and 1, the graph changes slower than the parent function, making it wider. The book uses compression and stretch. We're going to use narrower and wider, okay? A stretch would make it narrower, compression would make it what? Wider?
Yeah.
People tend to confuse those because they're like, what kind of a stretch? Because I can stretch things horizontally as well.
Usually when you think of compressing something,
Yeah, it
it's just like flip-flop.
right. So that's why I use narrower and wider. The book uses stretch and compress. So if you want to, in parentheses, narrower would be a stretch, a vertical stretch. Wider would be a horizontal compression. I just like narrower and wider better. But what's actually happening is the changing quicker and slower. And we will be making sketches. We won't be doing exact other than the vertex. Maybe the y-intercept. There'll be some exact points, but there'll be like an x-intercept, a y-intercept, a vertex. They won't just be random off. So then H, remember what H changed? You guys remember? The horizontal. So H is the horizontal translation of the vertex, and it's always the what? The opposite sign, isn't it? Now there's some other things that H tells me. X equals H is the axis of symmetry. I think I needed some more. If A is greater than 0, meaning it opens what way? If A is greater than 0, the graph opens up. Then x equals h is a minimum. There should be a comma after the 0. And if A is less than 0, I got it on the second one. If A is less than 0, so mean opens what? Down, then x equals h is a what? Maximum. So h actually is quite a few things, right? It's the horizontal movement of the vertex. It's the axis of symmetry. What does axis of symmetry mean? It's the same on both sides, right? Symmetry. Okay. And then A is greater than 0, it's a minimum. If A is less than 0, it's a maximum. And H is always, remember, the opposite direction of the sign, isn't it?
Yeah.
Okay, and what's K now? My shortest box for last. K is my vertical movement, and it's always the same as the sign.
That's what it really is.
Now, is this a review of what we already have done?
Yes.
So I'm just going to get a little bit more picky with it than I was before. This is the last of like the big stuff. Now let's just gonna do it. Because this is all the information we need.
Oh, it is.
I mean, like rule type.
Yeah, color coding it, like looks so much nicer. It doesn't all blend together and confusing.
Good.
I can tell the difference between what this and this equals.
So then what do you want?
You don't want to know the rest of it.
Okay.
Like that.
Tape.
Pretty complicated. No.
There's my computer. It's like 32 right now. I just checked it.
We can't be in here. You're talking about class.
Right. Okay, you done?
I just got to write the same, which is fine.
Feeling any good?
Oh, well, one more bullet. That's the very bottom for that. I mean, H.
Okay, so when we think about these things individually, they kind of make sense, right? So we're going to be asked to say characteristics. I mean, that's the learning goal, is to say, what is the axis of symmetry today? Can we identify that? What Once I have the H, do I know the axis of symmetry? Yes. Do I know if it's a max or min, if I know if it opens up or down? Yes, it kind of all goes together. Good now?
Yep.
Okay, so these are just two examples. We can talk about them. You don't really need to write them down. It says the equation shows the graph is translated 2 units to the left because I have a +2. Remember, that's always opposite, right? So what I always like to do is I write 0, 0. That's the original vertex, right? The parent function. And it's going to go where? It's going to go -2. And is there a k?
No.
No. So the k is what?
0.
0. Okay. So my vertex is going to go from 0, 0 to -2, 0. Yes? Is it going to open up or down?
Down.
Down. So I put an arrow like this. Okay. Now 1/2 is between 0 and 1, isn't it?
Yeah.
And if it's between 0 and 1, is the graph going to be wider or narrower than the parent function?
Wider.
Wider. So then I write wider. So I wrote all this stuff. Now let's see if it matches. So here's the parent function in blue. And in red, the vertex should be at -2, 0. Is it?
Yes.
Yes? And then is it wider than the first one?
Yes.
Yeah, not by a lot, but is it wider? Yeah. Now the other thing I didn't go over, is this a maximum or minimum?
Maximum.
So x equals -2 is a max. And I knew that because it's opening what?
Down.
Down. What is my A of S? What's A of S stand for? Anybody? A of S.
No, I don't know.
Look at your thing. Look at your thing you just wrote from the slide before. What do you
That means it's slower.
No. Next one. Look at your H box. What does A of S stand for?
Horizontal.
Axis of
Vertical. Symmetry.
symmetry.
Oh.
Axis of symmetry. Okay? And it tells me in that box that it's also what? X equals -2. And I should put dots here, not equals. Because if I took and made an imaginary vertical line, is this the same here as it is here?
Yes.
Yes. Okay, so we're going to go to the next one. Right here. And I usually go left to right. So does it open up or down?
Up.
Up, because it's positive. Okay? And 0, 0 is going to go to where?
Oh,
What's this 1 tell me, left or right?
right.
Right, 1. And -3 tells me
Down 3.
down 3. Okay? So my axis of symmetry is based off my H, yes? So my axis of symmetry is x equals what? -1, because that's what my H is. Now, x equals -1 is also, is it a max or a minimum? If the graph opens up, is this a maximum or minimum?
Minimum.
Minimum. Oh, I forgot this 2. What does that 2 tell me? 2 is greater than 1, so the graph is what?
Narrower.
Narrower. So I call this my roadmap. Should I be able to sketch that graph pretty easily now? Yeah, so let's look. The blue again is the parent function. My vertex went to 1, -3, right here. I should do a different color, but 1 here. And is it narrower and opening up?
Yes.
Yes. Is -1 my axis of symmetry?
Yes.
Yes. is -1 a minimum? Yes, because it's opening what? Up. And I didn't need the graph to do that, did I? Okay, describe the transformations from the parent function, then graph the function identifying the vertex, axis of symmetry, minimax, domain, and range. Okay, so I didn't do domain and range yet, but once I have a picture, will it be easy to do my domain and range? Should be. I don't want you to label things on the vertex with words. I want you to do it off like we did before, okay? So you're going to write the problem down. Got it written down, right? G of x equals negative the quantity x plus 2 squared. Okay? So, is this graph opening up or down?
Down.
Down. So that's what my down arrow is for. Then I know 0, 0, which is the parent function vertex, goes where? And let's put a V next to that. What would V stand for?
Vertex.
Vertex. So we'll label in our work so we know what we're looking at. That would be helpful, right? It's going to go down, and I'm just going to put V and then a colon. If my pen would show it, but I am. Okay, so where's my vertex going to go, guys? It's +2. So
-2.
-2. And what's my K?
Nothing to 0.
It's +0, isn't it?
Yeah.
So -2, 0. That's my vertex. Everyone good? The other thing we need is, what do we need? Axis of symmetry. Where do I get my axis of symmetry? A, H, or K? H. So my axis of symmetry is x equals what?
2.
-2.
I knew that.
Okay. Then what else does it say? Min or max?
That'd be minimum.
It would be a minimum. Would it be a minimum? It opens what direction, guys?
Oh, should be back.
Down. So it wouldn't be a minimum, it would be a maximum. So I'd have a max at where?
-2.
X equals -2. You need the x. And it says domain and range, but let's graph it first. Okay? So I'm going to put a D and an R, but we're going to graph it first. When you were graphing, I'm stickler about arrows on the positive X and Y axis at least. You can put it on all 4 if you want, but at least the positives, okay? So my vertex went to -2, 0. So 1, 2, 0. Unless I'm counting by 2s, I don't need to label it because you see 1, 2.
Yeah.
Okay? Which way am I opening?
Down.
Down? Okay, so I'm opening what? Down. And I didn't talk about wider or narrower because what's my A?
Negative.
No, what's the number?
1.
1. And so it's going to be the same, isn't it? Okay, so I have this. That's my picture. And this is how I label axis of symmetry. Right there. And what number is this?
-2.
-2. So do we label everything on the graph, basically? I don't know words.
Yes.
So what is my domain? Is there any restrictions on what number I can put in here?
No.
No. So what is my domain?
Infinity.
All real numbers, right? So I'm going to use set notation, x such that it is a set of all real numbers. Can I use interval notation?
Sure.
They say both things, yes? Okay, now range. This is range where you want to see your picture. Range are the y values. What is the, it's a maximum, right? Yes? So what is my maximum y value?
0.
0. So that's where I start, right?
Yeah.
So set notation would be y such that 0 is less than equal to y. Correct? Because it goes on forever. That's set notation. What would it look like in interval? I'd have a bracket. Why would I have a bracket?
Because it's your beginning point.
Right, but it's all, but I have bracket because it's equal to?
Yeah.
Okay, and my ending point is
Native.
negative infinity.
I hate making infinity signs.
Same.
So then you set notation and you never have to make an infinity sign.
And that's us. That way.
When we're in pre-calc, I will make you do set notation because we do some other things with intervals, so I always have you do set notation. Okay, so let's do it again.
Alright,
So it's for pre-calc.
Mhm.
I'm taking that extra.
so vertex,
There's no credit.
Okay, so left to right. Does it
Up.
open up or down?
Up.
Up, because it's positive, yes?
Yeah.
Is it wider, narrower, or the same?
same,
The same. And we'll just do same so we know we checked for it. How about that?
alright,
Okay? So it's up, same,
0, 0,
and we got 0, 0, which is the what? What is that?
the H,
Yeah, but what is it? What part of the graph is it?
the,
That part.
What is it? It's right here. What is it? What's this called?
the vertex,
The vertex. So I put a V, right? Yeah. Okay, so vertex was 0, 0. And now where is it going?
to the right,
To the right 1, because of my, right here. And then we're what?
2.
And up 2. So it's going 0, 0 to 1, 2.
yes,
Okay? So we know axis of symmetry, we should. A of S,
X is equal to
1. Now, we're going to go min or max. That opens up, is it a min or a max?
minimum,
Minimum. So it's going to be a minimum at what?
2, no, 1,
X equals 1 again.
Yes.
And I need the X, not just 1. Okay? Now we need domain and range.
yeah,
Any quadratic, guys, is going to guess what be?
X,
What's the domain of any quadratic until I put it
Infinity,
into
infinity.
any quadratic until I put it into a story problem is going to be all real numbers.
What do you put in the story problems?
Well, you may.
There are some serious issues.
Okay, now we need to do range. And let's see if we can kind of guess on the range before we do it, okay? Before we draw our picture. When we did the first one, it was less than the number because it was a what?
negative,
It was a maximum, wasn't it? So this one's a minimum, so it's going to be what?
higher,
Higher than that number, isn't it? So what is the y value of my vertex?
2,
2. So we think that it's going to be y such that y is greater than equal to 2. That's what we think it's going to be, right?
Yeah.
So if that's in set, so in interval, it would be
No.
bracket 2
infinity,
positive infinity, right? So let's see if we're right.
Definitely wrong.
You think we're wrong?
Well, the way that you've been talking, we're definitely wrong.
Okay, so the vertex goes to where? 1, 2, right? So 1 and 1, 2.
Yeah.
So there's my vertex. And it's the same as the parent function. Probably should, tomorrow I think we're going to start doing y-intercept. We'll figure out where it hits the y-axis, okay? But where it hits the y-axis, x is 0, isn't it?
Yeah.
So couldn't I just do it real quick? So if x was 0, I'd have 0 minus 1 is what?
1,
1. Well, negative 1. And negative 1 squared is?
1,
Positive 1. And 1 plus 2 is? 3. So it should hit right here, shouldn't it?
this is right, okay,
Oh, it's close. Just make it bigger. Okay? So 1 is my axis of symmetry, yes?
Yeah.
1, 2 is my maximum, or my minimum. What is my range right?
yes. This one,
What you doing today? Have we basically done this before? Yep. I think,
A lot.
Um,
7, 8. Oh,
okay, so this is
No,
just,
8.
9. 5, 15, 6.
okay, my directions last time were what? Describe, same thing, describe, yes? So I want you to try this one on your own. So I'll give you a minute or so, or two. I want you to try this one on your own.
You want some grab it? Do we need to have a point that it makes contact with?
What do you mean, like the y-axis?
Yeah.
If you want to practice that, that would be a good thing to practice. So let's use the y-intercept. We said put our x's to 0, right? So there'd be negative 4 squared minus 5, so negative 16, so negative 21. So that's going to be really far down. So you probably wouldn't show that on your graph, but that's a good thing to do.
I don't even have room for like the grabbing
Find a little bit of room.
What?
Can't find a little bit of room.
What?
part. I got it.
Just go to that.
Let's do it like this.
Oh, that's fine. But that's not negative 4.
It's not negative.
It should be negative 4.
4.
It should be negative 4.
Yeah, you flip it. Look at the one that you
Take,
A.
Oh.
right?
Yeah.
It should be negative 4. And that would mess up a lot of things if I didn't have my negative 4 right. It would mess up my axis of symmetry. It would mess up my maximum. It would mess up a lot of stuff, wouldn't it? So how did that go, guys? Found Peyton's.
Pretty simple.
Elon, how'd it go for you?
I got it.
Brad?
I haven't flipped well.
Okay. How'd it go for you, Brad? Okay. Remember that H is always the opposite sign. That H is always the opposite sign.
See, what I was thinking of was that negative 5 was on the X.
Oh,
Well, that's the same thing I did.
that's naughty. Don't do that. Yes, Tig.
Not for the range, I put -5 and then
So you have -5 is greater than equal to y?
Yeah.
Yep, that's fine. Because it's exactly the same thing, isn't it? I'm close to the y, both of them.
Yeah.
Mine says y is less than equal to -5. Yours says -5 is greater than equal to y. So they're the same.
alright.
Anybody else? Is that okay? Are we good?
Where, so there's the -1 times the x. Now, what does that do? How do you go about it?
-1 times the
Well,
x.
because the negative, so it would be -1. Before the parentheses.
Oh, you don't, that -1 just says it goes down.
Okay.
And the 1 tells me that's what? The same. You see how every single part of that I have something for? This is describing your change to me, guys. This is your work. Got it? Now, what's my x-intercept? Please tell me. None, right? So if I asked you my x-intercept, now I have a question for you. Some people try to solve these when they do their x-intercept, but if I know my vertex goes to -4, -5, and it goes down, am I going to have an x-intercept?
Do we have to find a y-intercept?
We
No.
not today, but we will start
If it
tomorrow.
goes below.
It's below, so it's never going to have an x-intercept, is it? Now, if I took the negative away, would it have an x-intercept?
Yes.
Yeah, it's going to have 2, actually, isn't it? Because it's going to come up in that shape of a parabola. So, you will be adding in x and y intercepts, but I don't think it's today. I think the next example is for tomorrow. Yes. But I bet we could do it. But
Are we done?
we are done for today, so you have the rest of the time to work on homework.